Alright, let's look at the homework 2.1, problem number 5. Alright, so we have a function f of x is equal to square root of x plus 3, and we want to find an equation of the tangent line to the graph of this function at the 6, 3. Alright, so let's do that. Alright, so since the point is already given, so I'm going to call it x1, y1. Alright, so only other thing we need would be a slope. So let's find a slope. To find a slope, we want to find the derivative. So let's use the definition. Alright, so here's the definition of the derivative. Remember that, right? Alright, so let's look at the f of x plus h. Alright, so every time we see x, we're going to put x plus h in it. Alright, so what we're going to have is I'm going to go ahead and replace f of x plus h. So we're going to have a square root of x plus h, and then you have a plus 3. Alright, so plus 3. So you get this. Alright. And then f of x is just exactly this formula there. So you just put, instead of f of x, we're going to put the square root of x plus 3. Right? So we get that. Right? So that's just following the definition. Right? Then when you evaluate the limit, the first thing you should try is just to plug in. But you realize that here denominator goes to 0. Right? And h is going to 0. So square root of x plus 3 minus itself. So the numerator goes to 0. So you have 0 over 0, right? Which indicates that you're going to have a common factor, and namely h, right? But you can see that the factor h is not very visible on the numerator. So we're going to have to do a little trick to kind of squeeze h out of the numerator, right? So here's a trick. So we're going to multiply top and bottom by almost same thing as the numerator except for the sign. So square root of x plus h plus 3 plus square root of x plus 3, and you do exactly the same thing to the bottom so that you don't change the value of the limit, right? And you notice that if you think of this as a minus b, then we are multiplying by a plus b, which is going to give you a squared minus b squared. Right? We get to square those terms, which is very, very convenient when it comes to getting rid of the square root. Right? So by getting rid of the square, go ahead and multiply out. We're going to get, let's see, so we still have a limit, right? The numerator is going to be, so this is going to be a squared, so you just have to remove the square root. So you end up getting x plus h plus 3. All right, so we got that. Then you have a minus sign, so I'm going to put the minus sign there. All right, then you need to subtract let's see, b squared, which is going to be just x plus 3. So I put x plus 3 in the parenthesis, right? Then the numerator, we can't really do much, so I'm just going to multiply the denominators together. So you have h times square root of x plus h plus 3 plus square root of x plus 3, right? So we get something like that, right? So what we can do is we can cancel things out. So for example, you have an x here and there's an x there. So let's cancel those. So we have x x here. I'm gonna cancel. Let's see, cancel that. Right? With we have to cancel the other x, right? So we're gonna cancel those. Right, and also you have a 3 minus 3, we can cancel those. So we're going to put, so we're going to cancel 3 there, and also cancel 3 there. All right, so let's see. We're going to end up, let's see, oh, I did something wrong there. All right, cancel. All right, now 3's are gone. All right, so you can see that there's only h left on top and there's a h on the bottom. Now we see the common factor. So I'm going to go ahead and cancel those h's. So cancel the bottom H with cancel the top H. So you're going to end up with, let's see, cancel to, this is going to become 1, right? So here. Alright, so the numerator is going to be 1, and here's the denominator. Right? So now we can take the limit. H approaches 0. So if you plug in 0 here, you have a 1 over square root of x plus 3 plus another square root of x plus 3. So it's going to be just a 2 square root of x plus 3. So you end up getting just that. Right? So since this is the derivative, right? So in order to find the slope of the tangent line at x equals 6, all you have to do is find, so m, we just have to plug in 6 for x in the derivative. So we just need to find f prime of 6, right? So we just have to plug in 6 in there. So you're going to get just that. All right, so 6 plus 3 is 9, square root is 3, so 2 times 3 is 6, so it's going to be simply 1 over 6. All right, so we got the slope. All right, so by point slope form, we're going to get, so y minus y1 is 3 is equal to, slope is 1, 6, we just found that, x minus x1 is 6. So we get that. And if you want, you can multiply it out. So if you distribute 1 over 6 to x and a negative 6, you end up with 1 over 6x minus 1, right? Because the 6 cancel out. All right, then if you want to isolate y, so you have to get rid of this negative 3, we can simply add 3 to both sides. So you end up getting y equals 1 over 6x plus 2. All right, so let's type this guy in. All right, so the equation is 1 over 6x plus 2. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, so next part is verify your result by using a graphing utility. All right, so I'm going to open up a GeoGebra here. All right, so we have f of x. So f of x was square root, so sqrt, then x plus 3. All right, so hit enter. All right, so we have a picture there. All right, then the tangent line came out to be y is equal to 1 over 6 x plus 2. All right, so it looks like that. All right, so here is the original function, and this is the tangent line we're looking for. All right, so here, let's see which one is the correct picture. Definitely not the first one. All right, so this one looks promising. All right, and here, let's go down here. All right, this is completely wrong, and this is completely wrong. All right, so there's only one reasonable one. We don't really have to look very closely because this is the only one that's reasonable here. All right, so let's pick that, and let's check the answer here. All right, so it came back here, and it looks like we got the correct picture as well. All right, that's it. I hope that this was clear.